All right, this is review for 6.3 and 6.4. No, 6.5 and 6.6. Now I want you to pay close attention to all the examples we're using this week on the board, on the PowerPoint, because they're examples that have multiple steps. Okay? I want you looking and because I think you've got the factoring. Now we're taking it a step further with the GCF and continuing to break things down. All right, so when I have more than 3 terms, we do something called factor by grouping. What would we do to factor this? Nicole?
You would put parentheses in front of 2 and closing at AP and then do another one.
Good, so we're going to put parentheses and we're going to group. And so when I group these two, am I grouping right away?
Nope.
Follow the chart. What's the first thing? Who just said that? Nicole, what do I have to do on my chart? What's the first thing? Before I factor by grouping.
You look at if it's plus or minus.
Nope. Caleb?
You factor out 2 because it's a GCF.
Okay, the GCF. We have to GCF. If you don't, I promise you there will be a mass of problems. Okay? Because you'll end up with something that's not completely factored. You can do it in the end, but you probably won't remember to do it in the end. Okay, so I'm factoring out my 2, and I'm left with px plus 4p plus 3x plus 8. No, 12. Now, I'm going to group. The thing to remember is we can move things around. They don't have to stay in this order. But I'm going to keep them in this order because this is nicely placed. And I'm grouping the p and the x and the 4p. There we go. Okay, what can we factor out of the first group? And please don't forget that GCF. It gets lonely if you leave that GCF up there. It wants to continue on. It feels like the kid that wasn't invited to the party. So please make sure and include that GCF. Okay, Jack. P for the first one, and what's left?
X plus 4.
Okay. And now, yes?
You can factor out 3 from the second.
A positive 3, and I'm left with?
X plus 4.
Okay. And now we can factor out our binomial. I'm not going to forget about my GCF. I can factor out my binomial, which is the quantity x plus 4. And we are left with our p plus 3. Okay. Now kids keep saying to me, do I need both? The brackets and the parentheses. Once I'm done, I can just switch to this. We're not distributing that 2. Okay, this is as good. This is the same thing as multiplying 3 numbers in a row. 2 times 3 times 4. I can multiply these 2 and then take the result and multiply by this. 12 times 2 is 24. Or I can do 2 times 3 is 6 and 6 times 4 is 24. But I'm not going to distribute that 2 to both numbers. Do you understand that? Because there's no plus sign in there. There's no plus sign in between these. So I don't distribute the 2. It's 3 different numbers that are basically being multiplied together. Only 2 of the numbers are binomials. Order doesn't matter. If I were to multiply these out, I could multiply these 2 first and then multiply by that. Or I could go the other way around. Start with the 2, multiply the 2 first into there, then take that result and multiply it here. Do you understand? We do not distribute that 2. Okay, questions? No. Okay, I want you to, we're going to try another one on our own. And I'd like you to continue on and do this one on your own. Pause the recording. Okay, what are we doing first? Okay. Ian.
So you factor out y squared for x squared, y squared minus y squared, and then you factor out...
Hold on. You're going, if you gotta speak to the way I'm writing. I'm factoring out a y squared and I'm left with x squared.
Minus 1.
Okay, and then, what am I gonna do? Leora?
Factor out the 9.
Plus 9. And what's left?
1 minus x to the second power.
Okay. Now, are these exactly the same?
No.
So that doesn't work. So Leora, can you think of another way to make them be exactly the same? They're almost.
You can switch the 9x squared with...
I don't need to switch it. There's no just switching. I got to do something mathematically. I need to make them become opposites. Saffron?
You put the GCF as negative 9.
It's not a GCF anymore because it's not out of everything, but I'm factoring a negative 9. Right? Now, what happens is this becomes a 1. 9 divided by negative 9 becomes negative 1. And negative 9x squared divided by negative 9 becomes plus x squared. Now I can move them around and make it x squared minus 1. But it's traveling with its sign. Do you understand that?
Yes.
Leora, does that make sense?
Yes.
I can't just make it become opposite. I had to factor out the negative to make them opposite. Then I can switch them around. Y squared, x squared minus 1. Okay, and what do I finish it up with? Kate?
You put in parentheses y squared minus 9.
Times?
X squared minus 1.
Perfect. Excellent.
Squared. But can't you factor out x squared minus 1?
Yes, you're right. I was banking on you guys forgetting that. Okay, so here we go. Times, what does it become?
X minus 1.
Okay, David? Oh, yes. Oh, I had no idea. Yes, the evil math teachers of the world are banking on you forgetting to factor all your difference of squares. Kate, you got one of them and forgot the other. Oops. Okay, so your final answer in these are the kind of questions I'm going to give you where you get to the end and you have to notice there's a difference of squares there. Okay, now, questions. Let's go on to, yes.
This one is x squared, y squared minus y squared 1 whole thing. Or is y squared 7?
Right here? Oh, is this one term? This is one term, just y squared. Y squared is not connected to the x squared, y squared. You can't just subtract that. It would have to be, it's its own term. Remember, everything that's attached has to be exactly the same to be combined. I grouped them, but they're different terms. Because this is 1y squared, and this is x squared, y squared. Okay? All right. Now we're going to move on to our factoring with a lead coefficient. All right. Whoops, edit undo. All right, so factoring with a lead coefficient. The first thing we're going to do, whoops, let me go back. Okay. First thing we're going to do, what steps do we take to factor when we have that 3 there in front of the x squared? Chris?
When you have that 3, you just make, when you do x marks the spot, it's just 3 times -4.
Which is negative 12 and negative 11. And what are my two numbers there? Platty?
-11 and
Not negative 11. Negative 12 and positive 1 or negative 1? Positive 1. Okay, so in the original problem, remember, we use the first term, we use the last term. 3x squared minus 4. And these, I'm really just breaking up this negative 11x by minus a plus x and minus 12x. So notice, because this is made up of x's, I'm breaking it up. Minus 1x minus 12x. And now I make a group. Okay, and in the first one, Jack,
You can take out
an x, and what's left?
3x plus 1.
Okay, and in the second group, Dariush, factor out
-4.
a negative 4, and what's left is 3x plus 1. And so my final answer is x minus 4 times 3x plus 1. Okay, questions? Yes.
Is this going to be on tomorrow's class?
Yep. Okay, I want you to practice doing number 2. Go. Pause the recording and do number 2. Okay, Ellie. Shh.
I multiply 2 and 10,
And we get?
20,
Good.
and put -5.
Okay. What are my two numbers?
-4 and -5.
Okay. What are the numbers I use out of the original problem?
2x squared and 10.
And inside, what am I going to have?
Minus 5x and minus 4x.
X. Okay, I'm going to group. And we factor out. And what's left?
2x minus 5.
And what am I factoring out of the next one?
2
Okay,
or
negative 2. And what's left, Ellie?
2x plus 5. No,
No.
minus 5.
When you factor out a negative, a positive divided by a negative makes it, oops. Oh, makes it negative. So it's minus 5. And so our final answer is x minus 2 times the quantity of 2x minus 5. Okay, questions? All right, let's kick it up. Because when you see this, it's not going to look like this. You're going to have a fraction that's going to be made of one numerator like this and well, I like the way they write this. What is a factor? Basically, you have to factor it and then answer the question. Okay, so what do we do first here? Gabby?
Find the common denominator.
No, not a common denominator.
Sorry. Common greatest factor.
Greatest common factor, which is 6. What is it?
It's not 6.
Okay, what is it?
It's 2x.
Good. And what's left?
3x squared minus 13x plus 10.
Good. So, Jairus, when I multiply, what goes up top
30,
and on the bottom?
-13.
Okay, and so now I've got 2x. I'm using what, Jairus? Keep going. How's it going to read?
Use the 3x squared, and then negative, or minus 3.
minus 3 and good. So you're doing minus what?
Minus
3x. Don't forget that because these two terms make up that middle term up there, negative 13x. Keep going.
times the quantity.
No, minus.
Minus 10.
And then?
Plus 10.
Good. Now, I'm going to group. Take the first two. And now I have, don't forget my GCF. What am I factoring out of the first group, please? Josh.
3x.
A 3x. And what's left?
X minus 1.
Good. And what am I factoring out of the second group, please, Gohar? Good, because we want it to become the same thing. What's left inside? When I divide this by negative 10, what's left? Huh? X. And when I divide this by negative 10, what's left? Negative 1. I don't write it like that, but it's basically what we're doing. Okay, and what's my final answer, Gohar?
It's 3x minus 10.
Okay. And that's my final answer? What am I leaving out? What's lonely, Gohar?
Oh, 2x.
2x. Okay, don't let that 2x be a wallflower. Okay, questions? Okay, we got one more to do. Shh, you're recording. Flatty. Shh. Okay. Okay. So, what goes up top?
16.
What goes down below?
Negative 17.
Last problem. Shh. So, shh. Here we go. Negative 17 and positive 16. What are my two numbers? Willie.
I put negative 16, negative 1.
Negative 16, negative 1. We use the first one. We use the last one. We get minus 16x minus 4x. Now, am I right? Remember when I break up... Shh.
Minus 1.
Oh, minus x. Right. Shh. Shh. When I break it up, remember this. This just serves to break up this term. And negative 16x and negative 1x do not make negative 17x squared. So I have to say it's minus 16x squared and 1x squared. Does that make sense?
No.
Who says no? Chris. Yes.
Wait, never mind.
All I'm doing, it doesn't matter. If this is to the first power, these are going to be to the first power. Since they're to the second power, these two are going to be to the second power. Does that make sense?
Yeah.
Okay, now I'm going to group. And what can we pull out of the first one? Nicole?
4x.
I can pull out a 4x squared, and I'm left with x squared minus 4. What can I pull out of the next one? Ian?
Negative 1.
Negative 1, and I'm left with x squared minus 4. All together now, I'm left with 4x squared minus 1 and x squared minus 4.
No.
Oh, phew, thank God we're done.
No.
Oh, my students are so so good they're not letting the evil math teachers of the world get to them. So, Andranik, tell me what to do. Shh. Shh. And that becomes? Which is? X plus 2. So for tomorrow's quiz, I'm going to be giving you a lot of these that you have to keep breaking them down, that have the GCF. So follow your chart. Think of these. You know factoring now well enough. When you left on vacation, you did not know it this well. So, things have changed. We've had a whole week of review. Yes.
Wait, how come in the other problem we didn't put x squared?
Because when it's like, here, let me do it in blue. Shh. Excuse me. Shh. When I have like 3... When I break this one up, right, we're doing what multiplies to negative 45 and adds to negative 4. It's negative. So the question is, why in this one are we not breaking it up right here for x squared? And that's because once we're only factoring this. Once I GCF'd out, I'm only factoring this part that's underlined in blue. When I went on to the next one, there is no GCF. So I have to factor this part. Does that make sense? Okay.